In this example, we're supposed to find total resistance, voltage across each resistor, and current in each resistor, and also I total. Anytime you have problem where all values of resistors are given, we're supposed to find total resistance first. Remember, the formula for total resistance of the series circuit says R1 plus R2 plus R3. This is nothing else than the sum of all resistances in the circuit. Please notice that anytime you see 2K, it means automatically 2 kilo ohms. So I have 2K plus 6.8K plus 3.2K. R total is equal, if you are going to add all these values together, you are going to end up with 12 kilo ohms. This is the total resistance of this circuit. Next, you're supposed to find total current. Even if the total current is not asked to be calculated just after R total, it's always good to calculate I total just after R total. So remember, the formula for current says current is equal voltage over resistance. In this case, I'm looking for I total, total current in the circuit. Remember, we are going to use always conventional current flow. We assume that current flows from positive terminal to the negative. And this is going to be my I total. So in this case, if I want to find I total, I have to divide voltage source by R total. Voltage source is equal 18 volts. 18 volts over R total, which is equal 12 kilo ohms. 18 volts divided by 12 kilo ohms is going to give me 1.5 milliamps. This is the total current in this circuit. Next, you have to remember the KCL, Kirchhoff current law, which says that in series circuit, all values of current are the same. I mean, we have just one current flowing through each resistor. So KCL for this circuit says that I total is equal to I R1 is equal to I R2 is equal I R3, which is equal 1.5 milliamps. Remember, in the series circuit, current is always the same at any point of this diagram. Next, we're supposed to find voltage across each resistor. Remember, Ohm's law says voltage is equal current times resistance. This is Ohm's law. If I want to find voltage across resistor R1, I simply multiply the current which goes through resistor R1, IR1, times resistance of resistor R1. In this case, this is going to be 1.5 milliamps because we said that IR1 is equal to I total and has value 1.5 milliamps times R1, which is equal 2 kilo ohms. This is going to be equal 3 volts. This is value of R1. VR2 is going to be equal IR2 in this case, because I'm looking for the voltage across second resistor, times resistance of the second resistor, equals 1.5 milliamps. Remember, one more time, current in this circuit is the same for every single resistor. That's why I keep using 1.5 milliamps times the resistance of the second resistor, which is equal 6.8 kilo ohms. 6.8 kilo ohms. Plug in these values into the calculator. Don't forget about the powers of 10, and you'll have 10.2 volts. This is the voltage across my resistor R2. If I want to find voltage across resistor R3, this is nothing else, just IR3 times resistance R3, which is equal, again, 1.5 milliamps, because my IR3 is equal to I total, 1.5 milliamps, times resistance of resistor R3, which is equal 3.2 kilohms. And this is going to be equal 4.8 volts. We got all currents and we got also all voltages. We found R total. We can say that this is end of the problem. But it's always good to verify that our answers are correct. Next, we're supposed to use KVL, Kirchhoff voltage law, which says that the sum of all voltages in the series circuit is supposed to give me voltage source value. So what I'm going to do, simply write the KVL for the series circuit, which says voltage source is equal VR1 plus VR2 plus VR3, which is equal VR1 is equal 3 volts plus VR2, which is equal 10.2 volts plus VR3, which is equal 4.8 volts. Add all these values together and you're supposed to end up with value of 18 volts. As you can see, the sum of these voltages gave me 18 volts. And this is the voltage which I start with. So I can say that all answers which I obtain are correct.